Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede. And it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
Prepare for blast-off, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. they have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor, literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are 2 possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years. Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon, and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, This beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere. But you packed a sweatshirt, right? It's gonna get pretty cold soon, like -300 degrees cold. The coldest it ever got on Earth was -128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're gonna send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're gonna have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it. Get ready for some beautiful pics of Titan's epic landscape. Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. It takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission: to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle, energy production. Probably some sort of nuclear power plant. Then comes shelter, for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem: gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus,
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri B. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri B is in the middle of the star's habitable zone, This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri B isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. It would take between 1,000 and 81,000 years for a spacecraft to reach Alpha Centauri if we used conventional propulsion. Plus, astronauts would have to deal with the countless risks of the mostly unexplored interstellar medium. But there might be a way out of this seemingly hopeless situation. Gram-scale spacecraft that rely on lasers when it comes to traveling through space. One of such concepts is called the Swarming Proxima Centauri, and it has recently been chosen for the NASA Innovative Advanced Concepts program. You see, traveling through interstellar space is a question of speed, energy, and distance. Proxima Centauri sits 4.25 light-years away from the solar system. That's 25 trillion miles, which is incredibly far away. For comparison, the farthest distance ever traveled by a spacecraft is 15 billion miles from Earth. Voyager 1 has been moving in outer space for more than 46 years, reaching a maximum speed of over 38 miles per hour. Traveling at the speeds that we can allow at the moment will make interstellar transit exceptionally long and totally impractical. And don't forget about the energy requirements such a journey would demand. Anything other than a tiny spacecraft weighing a few grams doesn't look feasible. But the solution might have been found. Bouncing photons off of a laser sail could solve the speed problem. But since a single photon doesn't have much momentum, a lot of them are needed. And since even in a couple of decades we probably won't have a lot of power available, the thrust will be weak. That's why the mass of the probes has to be minuscule. Not tons, but grams. The proposal suggests using a 100-gigawatt laser beamer, boosting thousands of tiny space probes with laser sails to a speed of 10 to 20% of the speed of light. This mission concept might be ready for development around mid-century. Then, the probes could reach Proxima Centauri as early as 2075. The researchers involved in the project have already demonstrated how a fleet of 1,000 spacecraft could deal with the difficulties of interstellar travel while maintaining communications with Earth. At the same time, the 8-year round-trip time lag caused by interstellar distances and general relativity makes it impossible to control the swarm of the probes from our planet. That's why the fleet must possess a great degree of autonomy when it comes to navigation and deciding what data should be delivered to Earth. One more issue is the cost of such a mission. The greatest expense will be the laser array, while the tiny probes might be reasonably cheap to produce. The scientists believe that their project can be developed with a budget of $100 billion. It's not so much compared to the usefulness of such a mission, which is likely to be astronomical. How come? Red dwarf Proxima Centauri, which is a member of the Alpha Centauri star system, has an Earth-like planet orbiting it, Proxima Centauri B. It's the closest exoplanet to Earth. Its mass is similar to that of our planet, and it travels in the habitable zone of its parent star. which means there might be water in this world as well as an atmosphere rich with oxygen. This planet might harbor life, or it could be a dry rock. In any case, it's a promising target in the search for alien life. Unfortunately, we can't detect the planet's biosignatures because our usual methods for detecting them don't work with Proxima Centauri B. Most exoplanets are discovered and explored through the transit method, where a planet regularly passes in front of its parent star, and we see a recurring dip in the star's brightness. That's how we know that the planet is there. But Proxima Centauri B isn't a transiting planet. It was discovered by a different method. When we look at the light coming from Proxima Centauri, we can notice that the gravitational pull of Proxima Centauri B makes the star wobble a bit. That's how astronomers found out that the planet was there. They also managed to estimate its size and mass. But no one can figure out much more than that. Hopefully, a swarm of tiny space probes will help us solve this mystery.
Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us, it's the planet orbiting it. That's Proxima Centauri B. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri B is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri B could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri B receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri B, this constant radiation would simply blow them off the planet. Proxima Centauri B is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright long-duration optical flare, accompanied by a series of intense coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri B, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri B? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri B. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri B really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri B. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system, Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years, but in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination. 1 million miles away from Earth, and then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, The biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. Twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler telescope, the TESS satellite, and the James Webb telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is. But we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, yet TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry them there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples. And this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, Researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us. Or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
We just can't get enough of Mars, can we? Everyone wants to go there, and astronauts are now looking at caves on the red planet where they can live once people inhabit it. The planet itself has some similar characteristics to Earth. Yeah, it's somewhat smaller than Earth, but the time it takes for the planets to revolve around themselves is also similar, which is about a day. On paper, Mars might seem like a good idea given some similarities to Earth, but there are some factors we need to pay attention to before we consider stepping foot there. The temperature. Mars might look like a scorching hot planet like a freakishly large Sahara Desert, but quite the opposite. It's really cold. Mars has a reputation for being a freezing, desolate, endless land that happens to have the largest mountain in our solar system thus far. So, within those mountains, astronauts and scientists are considering whether naturally built caves are the answer to our survival. Caves won't be the worst thing we'd live in considering our ancestors used to dwell in caves in communities. Logically, it's the best place to stay dry during a storm and keep warm. It's the best place for protection against predators like giant birds. elephants, and saber-toothed cats. We even had our first art shows in caves, with evidence of cave art dated thousands of years ago. Caves are a good idea, and they can also help us save a lot of money when establishing a colony on Mars. Rather than building a fresh structure in the middle of an open plain, the cave structure will help and influence the architecture, potentially saving lots and lots of money. Going to Mars will be expensive. It's already expensive sending people to the moon and launching a rocket into space. So, we have to consider the logistics. Another thing to look out for is caves in the ground that are not necessarily stuck on mountains. Scientists believe that most potential places for humans to thrive are caves. These spaces are large enough to host large populations. So far, they identified 9 caves as large as football fields. So what would life look like if we lived in caves on Mars? For one thing, sunlight would be hard to access. By the time we reach Mars, we would have the best technology to maximize our lifespan in a hostile environment, which means withstanding the harsh sun rays of Mars. Most likely, we would dig through the caves further underground where oxygen would be pumped for everyone to breathe. People can walk around casually, thinking they're on Earth, and to exit the caves, you would need to wear a special suit. These cave colonies would have dormitories for people to live in and special spaces for colony meetings, entertainment, grocery markets, schools, and other places that are needed to sustain a colony. There would also be indoor farms to grow crops and raise livestock. A team of experts mapped out what some of the dwellings will look like on Mars. And just like on Earth, we will have apartments for young professionals, family homes, and luxury mansions. Some of the dwelling units would be placed on the surface and not in caves. One of the key elements of the design and architecture is how to build it around the natural light to brighten up the homes. Another element is how to deflect radiation and cosmic rays. Because Mars has such a thin atmosphere, sun rays and other hazardous objects easily enter Mars. The dwelling units also have to be sturdy to protect them from severe dust storms and extreme cold temperatures. Some of the living pods or dwelling units that are for couples or singles would have tunnels leading to a shared workspace and garden. Studies show that even being in the presence of greenery can reduce stress levels significantly. And on the red planet, we would definitely need some greenery. We can expect the family homes to be built within the caves, not necessarily underground. It would be tempting to head outside with the view of Mars, but the large thick glass would prevent anything from coming in and out. Those who are underground with a view rely on LEDs and camera systems to screen the surface landscape of Mars so it acts like real windows. And if you're bored of the surface, you can always switch the channel and watch something else as you please. Maybe a flowing river surrounded by trees, or maybe a penthouse view of all of New York. The choice is yours. There would be a driveway that leads to a garage so one can enter and exit easily. There won't really be a reason to exit the cave colony except probably to visit other cave colonies. In this case, we would have highly crafted vehicles that will take people from colony to colony on the surface. The vehicles can withstand harsh temperatures and would be constantly transporting people daily. Some people might live in a certain colony and have to commute to work every day in other colonies. Humans might not have to be working in dangerous conditions or on the surface. We would have robots that will do that for us. The thing about robots is that they don't need to be human-shaped to do a job. However, before transporting humans to space, we would need to create some human-like robots and land them on Mars. With the exact physical form, we can determine what would happen to people if they were on Mars. We would have robots for specific tasks, helping us with everything. Let's not forget artificial intelligence plays a major role in monitoring the systems and updating the functionalities of the colony. It'll know when certain systems need fixing, adjusting, renewing, and changing. We also need people to keep an eye out for anything out of the ordinary, and also to make sure people are behaving and not breaking the law. Getting to Mars would be the earliest obstacle we will face. We've already launched some robots to explore the terrain and conduct some studies. At first, we would send robots to test the conditions and to build most of the infrastructure. To build a proper colony, we would have to send out young couples willing to dedicate their lives to the future and the future of their children. It won't be easy. In fact, there would be a variety of people with different professions and specializations to help establish the colony. People would have to work and establish a local economy. We would need scientists, doctors, farmers, teachers for the children, and engineers to maintain the structure. It will take time for the colony to reach a substantial size, but it's all part of the process. Even the spaceships would need to be large and sufficient to house thousands of people traveling from Earth. Of course, by then, most of the dwelling units would have been built, and people would have already picked out their houses, depending on if they were single or if they were about to start a family. Once the colony has the necessary professionals it needs, then come the other people who wish to start their life on Mars. People would need entertainment, so musicians would find a place in the colony. We can't expect everyone to go out on a nice sunny day to the beach, but perhaps one day, when the colony is large enough, there can be an artificial body of water with the same elements as the beach. Livestock animals would also be shipped from Earth to be raised on Mars, where they can populate for our nourishment. We can also bring most of the animals and establish a wildlife sanctuary for everyone to enjoy and for the animals to thrive. For now, humans are planning on reaching the red planet sooner than we think, and who knows, maybe you can be one of the first people to sign up and have your own little dwelling unit far away from Earth.
Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas. Or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere. Prepare for blastoff! because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor, literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are 2 possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.
Our universe is like a giant highway, and galaxies are constantly moving along this highway. And just like cars driven by careless drivers, they can collide and crash. So, astronomers have recently witnessed such an incredible cosmic collision. It involved galaxies traveling at incredible speeds. Using advanced instruments, researchers clocked one galaxy traveling at a speed of around 2 million miles per hour as it crashed into a group of other galaxies. This collision has created shock waves that are so powerful they can completely reshape the entire region, leaving long-lasting effects on its structure and dynamics. Will it somehow influence our solar system? Before we find out, let's learn more about the region where this collision occurred. Actually, this collision is still happening in Stephan's Quintet. That's a fascinating cluster of galaxies that has been the subject of study for scientists for over a century. It's a group of 5 galaxies located in the constellation Pegasus. This group of galaxies was first discovered in 1877 by the French astronomer Édouard Stephan, who used a telescope at the Marseille Observatory. Despite its tranquil name, Stephan's Quintet is anything but peaceful. It's a chaotic spot filled with galactic collisions and turbulence. 4 out of the 5 galaxies are gravitationally bound. It means they are physically interacting with one another. Such interactions are ejecting material from the galaxies, and over time, it forms vast debris fields in the space surrounding the galaxies. Astronomers believe that, in the end, these galaxies will merge into one giant galaxy, but it will only happen in millions of years. The curious thing, though, is that the 5th galaxy in the quintet, located in the upper left corner of images, is not part of the collision. This galaxy is much closer to Earth, more than 200 million light-years closer, to be precise. So its alignment with the other galaxies is just a chance perspective from our vantage point, making it appear as part of the group. Stephan couldn't know this in the 19th century, so the name quintet has remained, even though only 4 galaxies are physically involved in the collision. Now, how about we look at this collision in detail? At the center of this event is one of the galaxies in the group, which is currently crashing into the others at a breathtaking speed. From our perspective on Earth, this galaxy appears to be approaching the quintet from behind, heading directly toward the viewer. The collision is creating a massive shock wave that ripples through the surrounding galaxies. As the shock wave is moving through packets of cold gas, it's traveling at hypersonic speeds, several times the speed of sound in the intergalactic medium. This process strips electrons from atoms, leaving behind long trails of glowing ionized gas. But when the shock wave comes across regions of hot gas, it compresses the material rather than disrupting it. This compression produces radio waves, which can be detected by radio telescopes. While reshaping the structure of the intergalactic medium in Stephan's quintet, this shockwave also influences the future evolution of the galaxies involved. Now, how did scientists even manage to spot such a dramatic space event? All thanks to innovative technologies. The most important participant was WEAVE, a cutting-edge spectrograph that's installed on the William Herschel telescope in La Palma, Spain. This tool specializes in gathering spectroscopic data, which is the information about how matter absorbs or sends out light and radiation. It allows astronomers to examine the movement and composition of space objects with great precision. Besides WEAVE, researchers have used data received from a few other large observatories. One of those was LOFAR, Low Frequency Array. It's a radio telescope with an antenna network observing the radio waves the weaker shock wave produced while compressing hot gas. Astronomers combined the data received from all these instruments and managed to study the shock waves and their effects in amazing detail. This collision in Stephan's quintet gives us a fantastic opportunity to find out more about the interactions between galaxies, which can influence the evolution of the universe. You see, when galaxies crash into each other, their gas and dust gets redistributed, and it can trigger the formation of new stars and even cause central supermassive black holes to grow. And if we talk about Stephan's quintet, the ongoing collision in this area helps us get additional information about the behavior of gas under extreme conditions. Now, at the same time, galactic collisions aren't as rare as you might think. They're common on a cosmic scale, and in the early universe, collisions occurred even more frequently because galaxies were located much closer together. With time, such interactions have played a key role in shaping the universe. Even our own galaxy, the Milky Way, has experienced tons of past collisions. We can see the evidence of such destructive interactions in the form of debris streams and disrupted star clusters within the galaxy. In fact, astronomers predict that the Milky Way will collide with the neighboring Andromeda galaxy in about 4.5 billion years, eventually forming a new, larger galaxy. Even though they're moving at incredible speeds, galactic collisions are super slow processes from our human point of view. While galaxies may travel at millions of miles per hour, the distances they cover are so vast that mergers take millions to billions of years to complete. Now, galactic collisions don't look like explosive crashes you might be imagining. Instead, they resemble when fluid merges. When two galaxies collide, their gravitational forces distort their shapes. They stretch and warp, and exchange their material, stars, gas, and dust. As a result, tidal tails, rings, and even bridges between galaxies form. One of the most famous collisions between galaxies is ARP 148. During this cosmic crash, one galaxy became shaped like a ring, while the other stretched in a long tail-like form. That's how powerful gravitational interactions between galaxies during collisions are. But however impressive intergalactic collisions are, collisions between neutron stars, those ultra-dense remnants of massive stars, are among the most energetic phenomena in the universe. Neutron stars are incredibly small and dense. Just one contains the mass of our Sun packed into an area the size of a city. When two neutron stars collide, they often merge to form a black hole, releasing immense amounts of energy in the process. These events produce gravitational waves, ripples in space-time, that can be detected by instruments like LIGO and Virgo, as well as bursts of light that outshine billions of stars. On Earth, the possibility of a galactic collision directly affecting us is extremely low. Luckily, the timescales and distances involved make such events harmless to life on our planet. However, smaller-scale collisions, such as an asteroid impact, are more plausible. Asteroid impacts have occurred in Earth's history, and the most infamous of them caused the extinction of the dinosaurs 66 million years ago. And while large impacts are rare, astronomers closely monitor near-Earth objects to protect our planet from potential threats. Now, while we're talking about space collisions, a question may arise. Can life travel between planets? This is the idea of Lithopanspermia, the transfer of life between planets via debris from collisions. If an asteroid or comet hits a planet, fragments of rock could be ejected into space. If those fragments carry microbial life, they might land on another planet and seed life there. And guess what? According to experiments, certain super tough microorganisms like cyanobacteria could survive the harsh conditions of space travel, including radiation and re-entry into the atmosphere of another planet. In any case, Lithopanspermia is still only a theory and a controversial one among scientists, but it doesn't make it less fascinating. It might eventually help us understand how life could have spread across the universe. But let's return to the ongoing collision in Stefan's quintet. By studying such events, astronomers learn more about how galaxies interact, evolve, and influence their surroundings. Hopefully soon, we'll find even more interesting facts about this process. Stay tuned. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, It remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time. And as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data. including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian plateau has risen for around a half-mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So, they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow.
Under your feet, the moon is pulsing. You feel danger with every pore of your body. The lifeless satellite, or so you thought, stays still for a second before knocking you down to the ground with a powerful tremor. Is it a moonquake? For years, scientists believed the moon was completely inactive, but the newest evidence seems to suggest that this idea is totally wrong. Researchers from the University of Maryland have recently discovered 266 mysterious ridges on the far side of the moon. And these ridges likely point to recent geological activity. So, are we really talking moonquakes? Well, kind of. The ridges are located in volcanic regions that formed 3.2 to 3.6 billion years ago. But they appear much younger than expected. Typically found in clusters of 10 to 40. They're often located in areas where the moon's surface is structurally weaker. Now, when astronomers speak about recent, don't take their words literally. They don't mean last year or even decade. Most models scientists created suggested that the moon's geological activity ended 2.5 to 3 billion years ago. But the new information hints at the possibility that these formations have been active within the last billion years. Some of the smaller ridges seem to have formed as recently as 200 million years ago, and that is considered relatively young on the moon's timescale. It means that the moon may still be experiencing geological changes today. These discoveries kinda challenge our understanding of the moon's history and evolution. But how did scientists come to these conclusions anyway? Researchers from the University of Maryland and the Smithsonian Institution used crater counting to estimate the age of lunar ridges. It works like this. Surfaces with fewer craters are younger, and the more craters some region has, the older it is. Plus, the analysis showed that some ridges cut through already existing craters, meaning they likely formed around 160 million years ago. In geological terms, this is very recent, suggesting that these ridge-forming processes may still be happening. Another cool thing is that the ridges on both the near and far sides of the Moon are similar, which means they may have formed through the same geological processes, having been shaped by the same forces. These forces might include the Moon's gradual shrinking, thermal contraction, and shifts in its orbit. We'll talk about it a bit later. Another argument supporting the idea of a still active Moon is decades-old data from the Apollo missions. They had already detected shallow moonquakes with the Apollo Lunar Seismic Experiment, recording 28 quakes ranging from magnitude 1.5 to 5. Researchers believe that these ridges may be linked to similar seismic activity. Now, about that bizarre shrinking of our natural satellite. Scientists believe the Moon formed about 4.5 billion years ago when a Mars-sized object collided with early Earth. This catastrophic impact likely sent bunches of superheated material into space. Eventually, they came together and formed the Moon. In its early years, the Moon was just a molten world, shaking from intense volcanic and seismic activity. So, the Moon used to be a molten mess floating through space. But when did it actually solidify? Scientists have finally figured it out, 4.43 billion years ago. This was a huge turning point, not just for the Moon, but for Earth too. After all, the giant impact that formed the Moon might have also been the final blow that made Earth stable enough to support life. In any case, billions of years passed. The Moon gradually cooled and contracted. And now look at this modern-day rocky sphere illuminating our nights. But the Moon isn't completely rigid yet. It still keeps cooling. And this slow cooling of its core might be one possible reason for the Moon's continued activity. As it cools, the Moon's interior contracts, which leads to cracks and shifts in the crust. One of the clearest signs of this contraction is found in the lunar maria. See these large dark patches on the Moon? Those are called maria, areas formed when lava filled ancient asteroid impact craters and then solidified. Then, over time, the cooling and contracting crust created these wrinkle ridges. Another factor of the ongoing geological activity could be the Moon's gravitational interactions with Earth. Such non-stop powerful interactions likely create surface stress and trigger tectonic movements. It's all good and exciting, but can this activity on the Moon actually affect humans? In a sense, it can. The Moon has long been seen as a stable place for future bases and resource extraction. But the discovery of this ongoing geological activity is pretty worrying. If the surface is still shifting, future settlements, infrastructure, and mining operations could face serious risks. That's why, at the moment, we need seismometers and ground-penetrating radars to better understand these movements. It will allow us to assess potential dangers before any long-term missions begin. By the way, there's another potential problem future lunar missions might have to deal with, and it's moon dust, aka regolith. Apollo astronauts quickly learned that this jagged, sticky dust gets everywhere and can damage suits, equipment, and even health. A new study from Texas A&M engineers found another problem. When rockets land or take off, they kick up regolith, which can become a collision hazard, especially with many spacecraft bringing crews and cargo to the Moon. Lunar regolith comes in all sizes, from tiny dust particles to large rocks. The main ingredient in moon dust is fine silicate materials, about 70 microns in size, like a human hair. They formed over billions of years as meteors and asteroids smashed into the Moon's surface, grinding much of it into powder. Unlike Earth, the Moon has almost no atmosphere. It's incredibly thin, so there's no wind or water to smooth out the dust. On top of that, constant exposure to solar wind has given the regolith an electrostatic charge. making it stick to anything it touches. Apollo astronauts quickly found this out the hard way. Moon dust clung to their suits, got trapped inside their landers, and stuck to everything. Worse, it became a health hazard, causing eye irritation and breathing problems inside their spacecraft. But at the moment, it seems like a problem for future us. A much more important issue is finding water to support future missions, and China is going to deal with it. It's getting ready for a big mission to look for hidden ice on the moon. As part of the Chang'e 7 mission in 2026, a flying robot will explore deep craters at the moon's south pole, where ice might be trapped. If they manage to confirm it, this could be a game changer for future lunar missions. Astronauts will have a water source and even fuel for space travel. The mission is a key step in China's plan to land astronauts on the moon within 5 years. While signs of water have been found before, like in soil samples from Chang'e 5's probe and observations by NASA and Indian spacecraft, scientists believe that deep ice deposits are the real key to supporting future missions. The south pole of the moon has some incredibly deep craters, and experts think ice could be hiding inside them. The flying robot will try to explore one or more of these craters after landing. If it does find the ice, it could make long-term moon missions much cheaper and more practical, helping astronauts live and work on the moon. Some scientists also think that this discovery could offer us some clues about extraterrestrial life. In any case, whether we find water on the moon and learn to deal with that pesky dust or not, the recent discovery of those young lunar ridges is a game changer. If the moon is still geologically active, it means we don't know as much about our closest neighbor as we thought. What else could the moon be hiding? Are we really prepared for the idea that this lifeless satellite might actually be more dynamic than we imagined? Future missions, which might not be as safe as we once believed, will probably show.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
So the idea of panspermia is that life can travel through space naturally, like seeds being spread around the universe. It's been debated for ages, but we didn't have any proof until recently. Now, with new discoveries and research, we're taking it seriously. People used to think it was impossible for living things to survive being launched off one planet, traveling through space, and land on another planet. But turns out microorganisms can handle it. Scientists got interested in this again in the 70s when they found rocks from Mars here on Earth that proved it's possible for rocks to travel between planets in our solar system. They figured out some ways that materials can be sent into space and survive the trip. So yeah, panspermia might be a real thing after all. Basically, scientists were wondering if living things could have hitched a ride between planets in our solar system. But for that to happen, microorganisms would need to survive being launched off of one planet, flying through space, and then landing on another planet. So, scientists have done a bunch of experiments trying to simulate all those crazy conditions. They found that spores can survive each stress individually, and even combined stresses can be simulated in the lab. For instance, microbes could totally survive the trip from Mars to Earth or any other habitable planet in our solar system. And get this, it's not just Mars and Earth that could be swapping germs. There are all these cool moons around Jupiter and Saturn that might be habitable too, like Io, Europa, Ganymede, Callisto, Titan, and Enceladus. Plus, microbes can survive in space for years with just a little UV protection. Like they could be space superheroes with a dash of sunscreen. And if they're shielded by 6.5 feet of meteorite, they could live for 25 million years up there. That's longer than most marriages last. But wait, it gets crazier. Scientists found microbes on Earth that were brought back to life after 250 million years. That's like finding a fossil and then it jumps up and says, "Surprise!" All these discoveries have changed the game when it comes to finding life on other planets. We used to think life could only exist on cushy Earth-like planets. But now we know that extreme environments are fair game. And with our improved knowledge of these environments, we've been able to develop astrobiology, which is all about studying the origin, evolution, and distribution of life in the universe. Mars is one of the most promising places to look for life. We've found evidence that it used to have an environment similar to Earth, which means life could have flourished there. And get this, scientists found trace amounts of methane in the Martian atmosphere that could be produced by living organisms. Plus, they recently discovered subsurface liquid water lakes on Mars. So, maybe there are some Martian microbes chilling down there. Europa is another exciting prospect. It has a subsurface ocean that could support life similar to Earth's deep ocean hydrothermal vents or the Antarctic lake Vostok. And Enceladus has hydrothermal vents on its subsea floor and high-speed jets of water vapor and organic-rich particles gushing out from its southern region. So who knows what kind of alien creatures are lurking out there? Bottom line, space is wild and full of surprises. Who knows what kind of crazy stuff we'll find next? Yeah, that long explanation was all about panspermia. But that's definitely not the only theory about the origins of life in space. There's just panspermia theory, but there's also directed panspermia. This theory is a bit crazy though. It suggests that life on Earth was deliberately seeded by an advanced extraterrestrial civilization. This idea is based on the assumption that life is rare in the universe and that it's unlikely to have originated on its own on Earth. Directed panspermia is basically the idea that dudes from other planets intentionally sent life to Earth. I'm not kidding you. Some people think that extraterrestrial beings might have purposely sent microorganisms or even whole organisms to our planet to kickstart life here. The idea is that those dudes might have wanted to spread life throughout the universe, and Earth was just one of their stops. It's kind of like intergalactic gardening. They planted the seeds of life and let it grow. Now, this theory might sound a little out there, but some scientists actually take it seriously. They argue that it's possible that life on Earth is too complex to have just randomly formed on its own, and that an outside force had to have played a role. I personally prefer classic panspermia theory over this one. There's another theory called chemical evolution, and it suggests that life on Earth originated from simple organic molecules that formed spontaneously in the early Earth's atmosphere or in space. These molecules then combined and evolved into more complex structures, eventually leading to the formation of living organisms. The conditions on early Earth were different from what we see today. The atmosphere was mostly composed of gases like methane, ammonia, and carbon dioxide, and there was no oxygen. These conditions were conducive to the formation of organic molecules. One of the most famous experiments that supported the chemical evolution theory was the Miller-Urey experiment in 1952. In this experiment, Stanley Miller and Harold Urey simulated the early Earth's atmosphere in a laboratory and produced amino acids, which are the building blocks of proteins. This experiment demonstrated that organic molecules could be formed from simple inorganic compounds under conditions similar to those found on early Earth. Over time, these simple organic molecules combined and evolved into more complex structures, eventually leading to the formation of living organisms. This process is believed to have taken millions of years and involved many intermediate steps. While chemical evolution is still a theory, and there are still many questions to be answered about the origins of life, it provides a plausible explanation for how life could have arisen from non-living matter. Hey, ready for the next theory? Meet hydrothermal vent theory. This one suggests that life on Earth originated near hydrothermal vents on the ocean floor. These vents provide a unique environment where chemicals and minerals mix with hot water, creating conditions that could have supported the formation of organic molecules and the evolution of life. This theory is another idea about how life could have started on Earth. Basically, it suggests that deep under the ocean, there are these hot vents where water, heated by the Earth's core, comes out. These vents are full of minerals and chemicals that could have provided the perfect conditions for life to begin. Scientists think that the first living organisms could have started around these vents, using chemicals and minerals to create energy. Over time, these organisms evolved and spread out into other parts of the ocean. The hydrothermal vent theory is still being studied and debated, but it's an exciting idea that could help us understand how life began on our planet. The last, but not the least, RNA world hypothesis. This theory suggests that RNA, aka ribonucleic acid, was the first self-replicating molecule that led to the evolution of life on Earth. RNA is capable of both storing genetic information and catalyzing chemical reactions, making it a possible precursor to DNA and proteins. Basically, the name of this hypothesis is a fancy way of saying that life on Earth might have started with a molecule called RNA. RNA is like a cousin to DNA, which is what makes up our genes. Scientists think that RNA might have been the first molecule that could make copies of itself, which is a key part of how life works. The idea is that in the early days of Earth, there were all these chemicals and stuff floating around, and somehow these chemicals combined to make RNA. Then, because RNA could make copies of itself, it started to spread and evolve into more complex forms of life. It's still just a theory, but it's a pretty cool one. And who knows, maybe we'll find out one day that it's how we all got here. NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the Sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then, it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that's captured the imagination of humans for centuries, and it's something we've always dreamed of doing. One of the most popular candidates for this role is Mars, and this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres. Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground, it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures, and pressure, and, well, all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So, first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water. And by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful! There's also another option. A colony could be created underground. That is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small rocky world. That is, tools to extract and use local resources. Also, since there's no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, What about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres would cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas, or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So, even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth. And it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It'll require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world! So, if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
Guess what? The universe can get actual scars, just like when you fall off a bike. Well, here's why. Before the Big Bang, the universe was extremely hot, dense, and full of energy, and it seemed like everything was going well, until that all changed about 13.8 billion years ago. Then the universe exploded. After the blast, it expanded incredibly quickly. Our human brain can't even perceive how fast that expansion was. Sometime later, the universe started cooling down. As it did, giant, terrifying scars cutting through space-time appeared all over the place. And if we study these scars well, we can even get insight into time travel. These days, we call these scars cosmic strings. They're like stretch marks that appear when the skin expands too quickly. Or we could also compare them to cracks that form in the ice when it freezes. These strings are likely very thin, about the size of a proton, a positively charged subatomic particle. Yes, subatomic means smaller than an atom. The strings are also extremely dense and can stretch for light years. Now, imagine these cosmic scars floating through space, not interacting much with their surroundings. When two cosmic strings pass each other, they could warp space-time in such a way that it creates a time machine. If you were to travel along a certain path around these strings, you would end up returning to your starting point at an earlier time, which is traveling back in time. Now, let's admit it, this idea sounds like something from science fiction, but it's supported by cosmic string theory, and the math behind it seems to work. Unfortunately, no one has observed cosmic strings yet, so for now, it's still a theory. In 1991, one physicist proposed an idea for how cosmic strings could enable time travel. If two infinite cosmic strings passed each other in parallel, they would warp space-time, creating a time loop. This loop would allow someone to travel back in time. Even better, this idea doesn't contradict Einstein's theory of general relativity, which suggests that large objects can bend space and time. These bends in space-time could allow a shortcut through time. His now well-known concept of closed time loops also helps explain how wormholes might work. So, a wormhole is basically a theoretical tunnel connecting one place in space to another. Some people believe that by using such tunnels, we could create shortcuts for incredibly long journeys through the universe, which would allow us to visit other star systems and galaxies. So, let's say you manage to create a wormhole and even accelerate one of its ends to near the speed of light, and then you send it back to where it came from. Well, at that moment, those two ends are not synced anymore. One is in the past, while the other is in the future. And if you somehow manage to walk between them, you'd be time traveling. You could do something similar by placing one end of the wormhole near a powerful gravitational field, like a black hole, and keeping the other side near a weaker gravitational force. This way, according to the theory of relativity, time would pass more slowly nearer to the strong gravity side, and it would allow a particle or another chunk of mass to remain in the past relative to the other side of the wormhole. At the same time, if you decided to create a wormhole, you'd have to keep in mind that they are super dangerous. They might collapse all of a sudden. They're likely to be highly radioactive, or you could come into contact with toxic exotic matter inside. But let's get back to the math behind the cosmic string time machine idea. Admittedly, it is solid, but it doesn't mean such a time machine is possible yet. To use this way of time travel, we'd need to reach near light speed, and it might be impossible. According to Einstein's relativity, the faster an object travels, the more energy it needs to continue speeding up. In other words, we don't yet have the technology or energy sources to accelerate a spacecraft to these speeds. The idea of two infinite cosmic strings is also questionable because we can't create something that's infinitely long. So, while this time travel model is mathematically sound, the infinite nature of the strings would make this exact model impractical. At the same time, some scientists still believe that cosmic strings are a better possibility than most other models, like wormholes. In any case, before we can start considering time travel, we need to discover cosmic strings. Luckily, there's a group of astronomers working to detect low-frequency gravitational waves by measuring signals from a type of star called a pulsar. Now, pulsars send out regular pulses of radio waves, and by measuring small changes in the timing of these pulses, scientists can detect subtle shifts in space-time. Those changes are caused by gravitational waves, which are ripples in space-time. Now, so far, we've only detected gravitational waves coming from black holes. But in 2020, there was one strange signal that didn't look like it came from black holes. It could be coming from cosmic strings. And here, we need to mention string theory. According to Webb, the universe is made up of more than just the four dimensions of space-time. There are additional dimensions that are hidden from us. Plus, The basic building blocks of the universe aren't particles, but tiny vibrating strings. These strings can vibrate at different frequencies to create different fundamental particles. These strings, from string theory, could have stretched out during the early universe and become the very cosmic strings we've discussed. In the coming years, we might get more information about them from a space-based gravitational wave telescope called LISA. It's supposed to launch in 2035. But if the signals picked up in 2020 really came from cosmic strings, it could mean a huge breakthrough in physics. In this case, string theory would become the right framework for understanding the universe. It would completely change the way we think about the building blocks of our reality. On the other hand, even if the signals don't turn out to be from cosmic strings, this discovery would still be important. It would give scientists more information on what cosmic string signals might look like in the future. And while we're not yet at the point of time travel, the discovery of cosmic strings could take us one step closer to understanding the mysteries of the universe and maybe even the possibility of traveling through time. Now, time travel is a popular theme in science fiction, but in fact, moving forward in time happens naturally. Right now, you are traveling into the future at a steady rate of 1 second per second. However, scientists have discovered that this rate can change depending on speed and gravity. Einstein's special theory of relativity explains that time slows down as an object moves faster. The closer you get to the speed of light, the more slowly time passes for you, compared to someone who isn't moving at all. The general theory of relativity adds another factor: gravity. The stronger the gravitational pull, the more slowly time moves. Near massive objects, such as the surface of a neutron star, black hole, or even Earth, time runs more slowly than it does far away from these space objects. If someone were to stay near the edge of a black hole, where gravity is incredibly strong, only a few hours might pass for them, while thousands of years would go by for people on Earth. If they returned, they would have effectively traveled into the future. This is a real and scientifically proven effect. A real-life example of time travel, though on a tiny scale, can be witnessed in space missions. For example, this cosmonaut spent a total of 748 days aboard the space station Mir during 3 separate missions. Because Mir was moving at high speeds relative to Earth, it experienced time dilation. As a result, he aged 0.02 of a second less than had he stayed on the ground. Now, this difference may seem tiny, but it shows that time moves differently depending on speed and location. But while traveling to the future is scientifically possible, traveling to the past is much more complicated and controversial, and leads to logical paradoxes. Imagine you throw a billiard ball into a time machine. It travels to the past and collides with its earlier self. This prevents the ball from ever entering the time machine in the first place. A contradiction. Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s, when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable, some massive invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way center, and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, it's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless, more like cosmic puffy clouds than anything else. Scientists called them Fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose. And it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere. and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint: gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. A faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super-powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all.
Two astronauts are stuck in space right now. It all started when they heard this creepy, pulsing sound coming from inside their spacecraft. A noise that shouldn't even be possible in the vacuum of space. The situation got so strange that their return trip from the International Space Station was cancelled. What was supposed to be just a few days in space has turned into 9 months of a real nightmare. This situation is happening to NASA astronauts Butch Wilmore and his colleague Sunita Williams. On June 5, 2024, they left Earth with one mission: to spend about 24 hours traveling aboard the Boeing Starliner spacecraft until they reached the space station. They were supposed to stay there for only 8 days, working alongside the 7 astronauts and cosmonauts already aboard. After that, they'd head back to Earth on the Starliner. Simple as that. However, just as they were getting ready to return to Earth, something strange happened. Wilmore started hearing this bizarre noise inside the Starliner capsule. It sounded like a heartbeat, with steady intervals. The creepiest part is that space is supposed to be totally silent, since there's no medium for sound to travel through. There are no atoms or molecules to carry a sound wave, so there's no sound or echo. And no one can hear you scream. It is just total silence. So there's no way those weird sounds could be coming from outside the spaceship. The situation got pretty concerning, as the noise just wouldn't stop. On top of that, the astronauts couldn't figure out where it was coming from. I mean, they knew it was coming from a speaker inside the capsule, but they had no clue what was causing it. So, they decided to ask the experts at the Johnson Space Center in Houston for help. Before we continue, it's important to know that odd sounds in spaceships aren't uncommon. Back in 1969, when the Apollo Mission 10 entered lunar orbit, astronauts said they heard a mysterious music coming from the far side of the moon. It was like a whistling sound that lasted almost an hour. It was so bizarre that they thought no one would believe them. Specialists think the sound was caused by radio interference, maybe from a magnetic field or atmosphere. But here's the thing. The moon has no magnetic field and not enough atmosphere to cause these sounds. So, the mystery still stands. Something similar happened back in 2003. Chinese astronaut Yang Liwei was on his first trip to space, alone, aboard a tiny spacecraft, when he started hearing something weird. It sounded like someone knocking on the spaceship's body, almost like knocking on an iron bucket with a wooden hammer. But what was even stranger was that the sound didn't seem to come from either outside or inside the spacecraft. Li Wei never figured out what it was, not even after returning to Earth. The situation was eerie enough to freak him out, probably just like what happened to Wilmore and Williams. But in the case of the NASA astronauts, it looks like they found an answer to the creepy sound. According to the team at Mission Control, the sound was probably just a technical issue. They think it's a speaker feedback loop between the space station and the Starliner. So, that sounds like great news, right? Well, not exactly. Their problems were far from over. The audio issue was definitely a concern for the team at the Johnson Space Center, but honestly, there were a lot of other technical issues going on with their spaceship. Even before the launch, experts noticed a small but persistent helium leak. This could be a big problem because this gas powers the thrusters, which control the spacecraft's orientation, speed, and trajectory. But in this case, the specialists thought, nah, it'll be fine. The leak was at an acceptable level and posed little risk to the mission's success, so they decided to go ahead with the launch. But then, things got worse. Once the astronauts were in space, specialists noticed another helium leak, then another, and another. In the end, they found 5 leaks, which had the mission managers pretty worried, so they urgently contacted Wilmore and Williams. The astronauts were about to go to sleep when they got the order to shut down 2 valves on the spacecraft. That way, it would be safe again and still have plenty of helium left to get them home. And when they thought it was all over, turns out it wasn't. The Starliner also had issues with the thruster control system. The capsule had 28 small thrusters, and 5 of them had technical problems at some point during their trip. 4 of the thrusters were fixed pretty quickly, but 1 of them never worked again. So first, there were the helium leaks. Then the thrusters weren't working properly. And now, there's this weird pulsing sound coming from inside the spacecraft. It seems like the problems with the Starliner just kept piling up. Suddenly, it became way too risky to bring the astronauts home. That's why NASA decided to cancel their return trip. Actually, they delayed it, extending their 8-day stay on the space station to 9 months. So far, they're expected to come back to Earth in March 2025. But it's hard to say for sure, since this date has already been pushed back before. What we know for sure is that both astronauts are stuck in space right now, waiting for the NASA SpaceX Dragon spacecraft to bring them back to Earth. Until then, they're sharing their floating home, which is about the size of a 6-bedroom house with 7 other people. Being stuck in an orbiting laboratory and unable to get home is definitely a desperate and suffocating situation for most of us. But it looks like they're handling it pretty well. Both of them had already done 2 long-duration stays in orbit before, so despite their families, both astronauts are used to it. And they said they're grateful for the extra time in space. Before the mission began, NASA also made sure they understood all the risks of the flight, including the chance they might have to stay at the station longer than planned. That's why both Wilmore and Williams fully supported the new date for their return to Earth. And they've been keeping their minds pretty busy up there, doing a lot of scientific work. One thing they're really focused on is looking after the plant facility at the space station. Their team is testing different techniques to see how they could help crops grow outside Earth. Figuring out how plants grow in space and making sure they get the right amount of water and nutrients is really important, especially as space travels keep going farther and farther beyond the moon. A lot of people are concerned about their safety and health, but there's no need to worry. They're completely fine. Stays on the space station usually last about 6 months or more. Also, the place is well stocked with everything the crew needs, including food, water, clothes, and oxygen. NASA and its partners often send missions with extra supplies to make sure everyone feels safe and taken care of. If Wilmore and Williams feel homesick and have some free time, they can always email, call, or video chat with their family and friends. The Boeing Starliner spacecraft returned to Earth on September 2024, but it came back empty, without Wilmore and Williams on board. It traveled in autonomous mode after undocking from the space station. The Starliner re-entered Earth's atmosphere after 6 hours of travel, using parachutes to slow its descent before landing at the White Sands Space Harbor in New Mexico. The landing was a success, but NASA specialists wish it could have gone as originally planned. I mean, with Williams and Wilmore on board.